Hi, I think I'll go ahead and make two more CDF videos. I'm going to use the same CDF, this capital F, and do a bunch of examples with it, but on this page, on this video, I'll do A through I, and then I think I'll make another video with a few other probabilities. I think it's useful to see these. So let's start with this one. So what I've given you here is the CDF, the cumulative distribution function. And recall, this is the probability that x is less than or equal to little x. That's the definition of capital F of x. I thought we'd go ahead and start off with its graph. You don't have to draw it, but I really think it helps later when we're determining probabilities to have the picture in your mind. So let's go ahead and draw our function here. So it only takes on values at 0, 1, 2, and 3. So here's 0, 1, 2, 3. And this is the x-axis. And then this is capital F of x. This is going to be my probability axis. Eventually we know it's going to hit 1 because I'm going to, by the time I hit 3, I've accumulated all my probability. So this won't be a perfect graph. Let's go ahead and put a half in here. And maybe this will go ahead and be a quarter and then 3/4. Okay. So it's a little bit unusual here between this range. My x is part of the probability function, so as x is in this range, the probability changes, and what we've seen before is like a constant probability over an interval. So this will be a little bit different. Let me switch to red to draw the picture. So for x is less than 0, we have picked up no probability. So coming from the left to 0, I have 0. And when I hit 0, I draw an open circle because I haven't picked up any probability yet. But when I do hit 0, I pick up the probability 0 squared over 2, which is still 0, so I'm going to fill in this hole there. And I have the shape of a parabola between 0 and 1. So at 1, I end with an open circle at a half, like this, and you can see what the shape looks like. So if I wanted to know the probability, for example, what's capital F of 1/2? That's the probability that I've picked up until and including 1/2. So that's the probability x is less than or equal to 1/2. So I could come over here at my picture and put in a half. It looks like it should be about a quarter, and that's right by the function. So let me see. 1/2 is in this range, so that's, well, that's a lie actually, right? A half squared over 2, which is 1/8. Which, yeah, I guess that does, right? A half looks more like 1/8 than a quarter. So, for example, let me see if I wanted to know capital F of 1. That's the probability that x is less than or equal to 1. But unfortunately, notice that 1, I have an open circle, so it's not defined to be a half. It actually is the 1, right? When I finally hit it, it's at 2/3. So this is 2/3. That's the probability x is less than or equal to 1. So I picked up a half here, and then I make a jump there at 1 up to 2/3. So let's go ahead and draw 2/3 in here. So between 1 and 2, I don't pick up any probability at all, so we're just going to have this horizontal line until 2. And at 2, then I jump up to 3/4, so I've picked up the probability between 2/3 and 3/4. And that's going to jump me up here. I have a closed circle at 2 because I picked up the probability. I go until 3. 3, I pick up another 1/4 and jump up to 1. So there's the graph of the cumulative distribution function. And so let's just do one more over here. What's the capital F of, let's see, F of 2.5. That's the probability the random variable takes on a probability less than or equal to 2.5. And if we go over here, we go to the picture 2.5, you can see it's picked up 75%, or over here 2.5 is in this range, so it's 0.75. So now I thought we would use, you could use the function or you could use the graph to determine these probabilities. So probability x is less than or equal to 1. That's just f of 1, because less than or equal to is what this capital F of x represents. So f of 1, I just go up here where 1 is defined, it's 2/3. Or you could think of this f of 1, it's coming to 1 from the right hand side. So less than or equal to means you've already hit it, so you come to it from the right hand side, which is 2/3. So if I want strictly less than 1, that's f of 1 coming from the left. I haven't hit 1 yet, so up here, as you see, as I come to 1 from the left, my value is just going to be 1/2, right? I put 1, I haven't hit 1 yet. When I hit 1, I get 2/3, but coming from the left, I stick 1 in here, and the probability is 1/2. So actually, we're set up nicely for probably x is 1. That's this jump right here, right? I mean, x is 1. This is the amount of mass the function takes on at 1. So if you want to write it more seriously, I guess we could say that's the probability x is less than or equal to 1 minus the probability that x is less than 1, right? Because I have a closed circle than an open circle, which is f of 1 from the right minus f of 1 from the left. And so f of 1 from the right, we had up here as 2/3, and then minus 1/2. And I'm not going to calculate. That's how much mass we have at 1, or probability at 1. I'm not worried about that right now, but that you see that the probability right there at 1 is that jump. Okay, so I don't want to get rid of this. So less than or equal to 2. That's just f of 2, or f of 2 from the right. So coming at 2 from the right is 3/4. Okay, now we have strictly less than, so that's f of 2 coming from, f of 2 coming from the left. So here's 2 from the left is 2/3. So at 2, you can see we actually picked up probability because we made the jump from 2/3 to 3/4. So back in my picture, that little jumping area, that's going to be the probability at 2. So this again would be the amount that's less than or equal to 2 minus the probability you're strictly less than 2. And whatever we get here then is the probability that x equals 2. And I'll just go up that picture really quick. That's going to be the value of that little jump right there. Okay. And I didn't leave myself much room, but I have just one more set of values. Let's see if we can do them. So less than or equal to 5, this is capital F of 1.5. I go up here, 1.5 is in this range, and it's just 2/3. You can think about coming from the left or right of 1.5, and it's still 2/3. So over here, 1.5 coming from the left, it's in that range, it's still 2/3. And last is the probability you're strictly equal, x is equal to 1.5. It can't be equal to 1.5. It's not gaining any probability, right? I mean, over here on my graph, let's go to the graph at 1.5. Here's 1.5. Notice I'm not picking up any probability at 1.5. I'm just constant along that line. So I know I don't have any probability there. So how I'm going to do this, if you, again, want to go up to what we did before, I could say that's f of 1.5 from the right minus 1.5 from the left, which is 2/3 minus 2/3, which is 0. So I think that's all I have on this one. I just wanted you to get used to understanding capital F means less than or equal to coming from the right, strictly less than a number. You haven't picked it up yet, so you have to come to that x from the left, at least graphically. And in the next video, I'm going to show a couple different inequalities too, and I also have a less than or equal to. So we'll explore that in the next video, but for now, I hope that makes sense. There's the picture, and I'll do one more, but if you watch these and still want another, just let me know. Okay, I hope this isn't too long. Oh, good, under 10.